The second axiom depending on perpendicularity, and the fourth axiom of congruence, is that if R and A be a rect, and an event particle in the same moment, and AB and AC be a pair of rectangular rects intersecting R in B and C, and AD and AE be another pair of rectangular rects intersecting R in D and E, then either D or E lies in the segment BC, and the other one of the two does not lie in this segment. Also, as a particular case of this axiom, if AB be perpendicular to R and in consequence AC be parallel to R, then D and E lie on opposite sides of B respectively. By the aid of these two axioms, the theory of congruence can be extended so as to compare lengths of segments on any two rects. Accordingly, Euclidean metrical geometry in space is completely established, and lengths in the spaces of different time systems are comparable as the result of definite properties of nature which indicate just that particular method of comparison. The comparison of time measurements in diverse time systems requires two other axioms. The first of these axioms, forming the fifth axiom of congruence, will be called the axiom of kinetic symmetry. It expresses the symmetry of the quantitative relations between two time systems when the times and lengths in the two systems are measured in congruent units. The axiom can be explained as follows. Let alpha and beta be the names of two time systems. The directions of motion in the space of alpha due to rest in a point of beta is called the beta direction in alpha, and the direction of motion in the space of beta due to rest in a point of alpha is called the alpha direction in beta. Consider a motion in the space of alpha consisting of a certain velocity in the beta direction of alpha and a certain velocity at right angles to it. This motion represents rest in the space of another time system. Call it π. Rest in π will also be represented in the space of beta by a certain velocity in the alpha direction in beta and a certain velocity at right angles to this alpha direction. Thus a certain motion in the space of alpha is correlated to a certain motion in the space of beta, as both representing the same fact which can also be represented by rest in π. Now another time system which I will call sigma can be found which is such that rest in its space is represented by the same magnitudes of velocities along and perpendicular to the alpha direction in beta as those velocities in alpha along and perpendicular to the beta direction, which represent rest in π. The required axiom of kinetic symmetry is that rest in sigma will be represented in alpha by the same velocities along and perpendicular to the beta direction in alpha as those velocities in beta along and perpendicular to the alpha direction which represent rest in π. A particular case of this axiom is that relative velocities are equal and opposite. Namely, rest in alpha is represented in beta by a velocity along the alpha direction which is equal to the velocity along the beta direction in alpha which represents rest in beta. Finally, the sixth axiom of congruence is that the relation of congruence is transitive. So far as this axiom applies to space, it is superfluous, for the property follows from our previous axioms. It is, however, necessary for time as a supplement to the axiom of kinetic symmetry. The meaning of the axiom is that if the time unit of system alpha is congruent to the time unit of system beta, and the time unit of system beta is congruent to the time unit of system gamma, then the time units of alpha and gamma are also congruent. By means of these axioms, formulae for the transformation of measurements made in one time system to measurements of the same facts of nature made in another time system can be deduced. These formulae will be found to involve one arbitrary constant which I will call kappa. It is of the dimensions of the square of a velocity. Accordingly, four cases arise. In the first case, kappa is 0. This case produces nonsensical results in opposition to the elementary deliverances of experience. We can put this case aside. In the second case, kappa is infinite. This case yields the ordinary formulae for transformation in relative motion, namely those formulae which are to be found in every elementary book on dynamics. In the third case, kappa is negative. Let us call it negative c squared, where c will be the dimensions of a velocity. This case yields the formulae of transformation which Larmor discovered for the transformation of Maxwell's equations of the electromagnetic field. These formulae were extended by H.A. Lorentz and used by Einstein and Minkowski as the basis of their novel theory of relativity. I am not now speaking of Einstein's more recent theory of general relativity, by which he deduces his modification of the law of gravitation. If this be the case which applies to nature, then c must be a close approximation to the velocity of light in vacuo. Perhaps it is this actual velocity. In this connection, in vacuo must not mean an absence of events, namely the absence of the all-pervading ether of events. It must mean the absence of certain types of objects. In the fourth case, kappa is positive. Let us call it h2, where h will be of the dimensions of a velocity. This gives a perfectly possible type of transformation formulae, but not one which explains any facts of experience. It has also another disadvantage. With the assumption of this fourth case, the distinction between space and time becomes unduly blurred. The whole object of these lectures has been to enforce the doctrine that space and time spring from a common root, and that the ultimate fact of experience is a space-time fact. But after all, mankind does distinguish very sharply between space and time, and it is owing to this sharpness of distinction that the doctrine of these letters is somewhat of a paradox. Now in the third assumption this sharpness of distinction is adequately preserved. There is a fundamental distinction between the metrical properties of point tracks and rects. But in the fourth assumption this fundamental distinction vanishes. Neither the third nor the fourth assumption can agree with experience unless we assume that the velocity c of the third assumption and the velocity h of the fourth assumption are extremely large compared to the velocities of ordinary experience. It must be the case the formulae of both assumptions will obviously reduce to a close approximation to the formulae of the second assumption, which are the ordinary formulae of dynamical textbooks. For the sake of a name, I will call these textbook formulae the orthodox formulae. There can be no question as to the general correctness of the orthodox formulae. It would be merely silly to raise doubts on this point, but the determination of the status of these formulae is by no means settled by this admission. The independence of time and space is an unquestioned presupposition of the orthodox thought which has produced the orthodox formulae. With this presupposition, and given the absolute points of one absolute space, the orthodox formulae are immediate deductions. Accordingly, these formulae are presented to our imaginations as facts which cannot be otherwise, time and space being what they are. The orthodox formulae have therefore attained to the status of necessities which cannot be questioned in science. Any attempt to replace these formulae by others was to abandon the role of physical explanation and to have recourse to mere mathematical formulae. But even in physical science, difficulties have accumulated round the orthodox formulae. In the first place, Maxwell's equations of the electromagnetic field are not invariant for the transformations of the orthodox formulae, whereas they are invariant for the transformations of the formulae arising from the third of the four cases mentioned above, provided